We are surrounded by electric circuits. We define an electric circuit as a closed loop through which electricity freely flows. The lights in your room are all powered by electric circuits. Your television, the computer you are using to read this lesson, and even your cell phone are all powered by electric circuits. Yes, electric circuits are very common nowadays in our electricity-reliant society. When you turn these electric circuits on, you can see their energy and power at work. When you flip the switch for the lights in your room, you see your lights get bright and begin to emit light. When you turn on your television, you see the screen on your television turn on, and you can see various television programs brought to you by your local television providers. When you turn on your computer, you will see your monitor turn on, and then you can use all kinds of computer programs on it. When you turn on your cell phone, you are able to make phone calls and write texts to your friends and family. Where does this power and energy come from? It comes either from batteries or from your electricity provider. Since we are dealing with electric circuits, we are also dealing with electric power. We define electric power as the rate at which a circuit uses electrical energy. Electrical energy is the charge that comes from a battery or from the power plant. There are two ways to calculate this power. We can use either the voltage or the resistance of a circuit. To use the voltage of the circuit, we can use this formula to calculate the power. P is equal to V times I. We have that power is equal to the voltage of the circuit times the current I of the circuit. When our unit for voltage is volts, V, and the unit for current is amperes, or amps for short, A, then we have to multiply them together to get the watt, W, the standard unit of power. So say we have two 2.5 volt batteries connected together to make 5 volts. If we send a current of 0.5 amperes through it, we get a power of P equals 5V times 0.5 A, which is equal to 2.5 W. You can power a clock with 2.5 watts of power. Another way you can calculate power is by using the amount of resistance in a circuit. You can actually convert the power formula with voltage into the power formula with resistance by using Ohm's law, which tells you V is equal to I times R. Voltage equals current times resistance. P is equal to V times I. P is equal to I times R times I. P is equal to I squared times R. Or P is equal to V times I. P equals V times V divided by R. P is equal to V squared divided by R. If you are given the current and resistance, you can use P is equal to I squared times R to find your power. If you are given the voltage and the resistance, then you can use P is equal to V squared divided by R to find your power. For example, say you are given that a certain electric circuit has a resistance of 1500 ohms, with a current running through it of 5 amps. The power used by this circuit is then P is equal to I squared times R, which equals 5A squared times 1500 ohms equals 25 times 1500, which equals 37,500 watts, or 37.5 kilowatts. This is almost enough to run a curling iron. Now, say you are given another electrical circuit that is run with 120 volts and a resistance of 192 ohms. You use P equals V squared times R to find the power this circuit uses. You get P is equal to 120V squared divided by 192 ohms, which equals 14,400 divided by 192, which is equal to 75 watts. This is enough to power a sewing machine. Let's review what we've learned. An electric circuit is a closed loop through which electricity freely flows. Electric power is the rate at which a circuit uses electrical energy. The formula to find the power in a circuit is P is equal to V times I. We use Ohm's law, V is equal to I times R, to derive two other power formulas that use the resistance of a circuit. P is equal to V times I, P is equal to I times R times I, P is equal to I squared times R. Or, P is equal to V times I, P is equal to V times V divided by R, P is equal to V squared divided by R.